Hello. I am starting in about 10 minutes, and when we get there, I'll explain everything I intend to do. See you then. Oh, it has officially started. Let me grab everything I need, which I think this should be it. So this video or stream, if you're watching live, is a tutorial. Not really a tutorial, just something I made as a startup guide, or not even startup guide. It's just something I wanted to do. It's just have a little bit of fun, learn a thing or two on the way. I'm gonna try and reverse engineer a single function of a GBA game. But before I start, I wanted to present concept. Exactly what is reverse engineering, what is the program, ROM, RAM, simple stuff, which I'll explain up like right now. That one, I am no authority. I don't know everything basically. I'm no authority. Authority. I shouldn't be speaking. You shouldn't be taking everything I say as the truth, because I am a numbnut, and I do get a lot of things wrong. But I prepare myself to present everything to the best of my abilities. If you see something I commented on that is blatantly wrong or just wrong in general, I would appreciate you helping me out and letting me know. But I think that's it. The idea is to go through the stages of my notes here and present everything. I myself try and explain, answer those questions, and explain a bit about programming and about reverse engineering, and about how computers work in general. Then I'll show the tools we're gonna use to reverse engineer. And finally, we are reverse engineering a single function. And by reverse engineering a single function, I mean giving it a name, finding out the parameters, and yeah, I think that's it actually. Just naming everything, the parameters, function name, and all the local variables and everything. So it's human readable in C again. I'm not really sure what I'm going to reverse engineer. That's something I'm gonna have to find out as we go. Okay, let's start. So in the first stage, the first question I proposed to myself in answering is, what does a program look like? And here on the left, I have created a simple program. It is like the main function, a function, and libraries. I'll go from top to bottom explaining each segment. These two guys, the hashtag, or I think it's hashtag, I don't actually know the name of the thing, but hashtag include, and then stdio.h and time.h. These are libraries. The idea of a library is a agglomerate or a conjunction. I don't know if conjunction is the right word. Let me check. A set. There we go. A series, aggregate, mess. I have Google Translate open for the rest of the stream. But a set of various functions. Usually, the name of the library gives you an idea of what those functions what is the general idea of those functions. So the first one we have std, which is a contraption, whatever, fuck it. The shortening of the word standard, and I and O stands for input or output. It is usually the most used. Like it has basic functions basically to print on a terminal and to I think it's the ones that have memory management stuff to allocate memory, which I'll not get into. Then we have our first function. A function is read as follows. The first word of a function is its return value. What we know about this function just by the first word is, what is it returning to me? When I call this function, what do I get back? If it says int or int, it is integer. Integer being numbers, complete numbers that do not have precision points. So I'll get either 0, 1, 2, 3, 4, 5, and so on and so forth from this function. I know that. The second word we have for a function is its name. So I have this function, it's called sum. Very simple. Whenever I want to call this, whenever I want my code to call this function, I use its name, just like you would call someone in real life. You call by the person's name. Then we have open parentheses, and inside this parentheses we have two other integers. We have integer x and integer y. These are called parameters. Parameters are what we give the function for each work. So to use my sum function, we need two parameters. Both must be integer values, and inside and then we have the curly braces. Inside the curly braces are the step-by-step our program will run through, and in this example it is a single line called return x plus y, which are my parameters. I think it's really easy to understand that all my function does is take two numbers, sum them together, and return this value, because that's what it does. So we now understand, or we have an idea, a very, very simple idea of what a function is. We'll go to the main function, which follows a very, very similar structure. The difference being the return of a main function is always integer, and it should always use two specific parameters, then being the amount of arguments and the arguments themselves, which I will not get into. You can see this is already a bit different from what we've seen so far. We have brackets and not an integer here, and this asterisk, which is not multiplying. I will not get too much into that, but the main function is obligatory in a program. As far as I know, at least, but I'm super sure it is. It is the actual first step of a program. It is built in the compiler, which we'll get into, that whenever you compile a program, it always starts by the function main. Inside this function main, we have a few different things. Those being a string, texting memory called mirror, a integer, which I don't think I need this. Actually, I do need this long here. Actually, I don't. Fuck it. I'm not gonna use it. A integer called myInteger, and its value is 97 by default. Because not by default, what I put there. We have a character A and an integer that is the sum of the numbers 1 and 2. And then below that we have two messages. They will be shown on the terminal. It is actually being shown on the terminal right here because I was testing some stuff. My sum's value is, and then trust me, this shows the number. Basically, it is saying get the first argument I pass for this function. Oh yeah, parameters, arguments. I think it should be all the same, I think. Or at least parameter is what you define here, and arguments what you're passing. I think that's the nomenclature. Just trust me, it is actually getting this value of my sum and put it in here. Same goes for texting memory, and we have the message Kirby and the amazing mirror. As you can see, it's not actually written mirror here. We're getting the value of texting memory, which is mirror. So this is my functions, like this is my program. Yeah, it is. Hopefully it is easy to understand and to follow up on. Second question is what it means to compile. Well, if you ever speak to a like programming teacher or professor or whatever, it is very common for them to say the computer is very dumb. It cannot think for itself, it only follows orders. And that is very, very true. For a computer, it is very recurrent. We hear that computers run in binary code. Only zeros and ones and bits and bytes and stuff like that. Which is also very true. So how come this program is running? Like, how come the computer understands that I'm saying to it, hey, print this, and then a bunch of characters. Characters are not zeros and ones. Yes, they are. But we'll keep it at they're not for now. How does it know that what is written here, if only works in zeros and ones? Why am I not going 0, 1, 0, 1, 0, 1, 1, 1, 0? Well, it is very simple. It is the work of a compiler. A compiler transforms code that is readable to human beings into instructions, bytecodes, and zeros and ones, basically. And it does that through just being called on a terminal. For this example, we are using GCC, and ignore this for now. We give him the file that we're editing, which is called rom.c, and then we name it rom.txe and run it. You will see, this is usually not shown, but I just asked him to. But you'll see there is a lot of messages, with the final one being my program running. That's why it's showing the messages that I asked it to. So yeah, it's getting my program, which is written in C, and transforming it into a binary. The final result of a compilation, it is a file. Usually Windows users know it as an executable file, a .exe. And it looks a bit like this. As you can see, it doesn't really... just so I get everything across. It's the left column. Well, all the numbers in the left column. The decoded text over here, it is trying to make making it easier for us to understand as humans. But what we get is hexadecimals. This is what a binary look like. Hexadecimals and binaries are basically the same. It is two ways of reading the same thing, much like tomato and tomato. They have the same meaning, but one is really hard for us to read, and the other one is just hard for us to read. Binary being the one that's very hard, because you would have to parse 8 positions instead of just 2. So if I were to be reading this in binary, each column instead of 2 characters, I would have 8. And then would be all 0s and 1s. So yeah, each step of the way, each little guy is actually a byte, a binary byte, or a hexadecimal byte in this case. And the computer now understands whatever single one of these means. And it goes through the code, every single line. You can see some stuff sound like is looking a bit suspicious already. But it goes through every single one of them. And you see this file is very large. Sometimes this file doesn't even have anything written on it. Zeros means actually nothing. But every now and then it has a bunch of stuff. And it's over. If you ask me right now why it has so much empty space, I would not be able to tell you, to be honest. I don't actually know. I guess I'll look up after. That is, I should be making notes. Well, I'll try and remember. Yep, but this is what our program looks like to the computer, and it can run this flawlessly. I'll just run it again. It's called rom.exe. There we go. This is Rex. I think it's what is hex. I have explained what is hex. So, what does hex look like? This is what hex look like. What are bytecodes? Okay. I will not be able to find specific cases. We will have a look at them. Real cases, at least. We'll have a look at them up ahead, basically, because I will be showing you Ghidra and how it works and what it does, which will be a real example. This is just a hypothetical example, which is easy to follow, so it doesn't really matter that much. Let's say we have these 4 guys, okay? We have F3, OF, O0F, 1E, FA. There are some stuff programmed in the CPU, the CPU being the hardware part, which take these 4 hexadecimal values, and because of how it works in bare metal, or as close to bare metal as you can get, it already knows that these 3 guys mean, hey, sum. And then the next 4 guys is going to be the first parameter and then the second parameter, right? So basically, it is not actually one-to-one like this. It is the same. Oh, I should be getting rid of this. Remove selected. Remove selected. Oh fuck! I destroyed the music. My bad. Hang on. It should be back. Is it back? It is back. Okay. Going back, what is byte? It is not actually one-to-one with the like, it's not one-to-one as in that's in function, that is the first parameter, that's the second parameter, but it's by and large the same. It is by and large that. So the instruction that says to the computer, hey, you're summing these 2 values, which, by the way, is a real function inside the computer. It is a real bytecode. That's the bytecode, yeah. And usually those instructions, so if this instruction is always will be add to the next two values, technically we could translate this into a readable, human readable ADD, right? Add. We could say this is add. And yes, we do that sometimes, and it's called assembly. Assembly instructions are the human readable form of executables, what the computer reads. So C is the human readable form to program large scale stuff, or larger scale, or easier to understand, easier to human read. Then that's transformed into hexadecimals, which is readable as assembly, but not as easily readable as C, but it's still human readable. We'll see examples of all of those soon. And finally, what does it mean to decompile? Well, decompiling is getting the readable assembly form, looking at it, and rewriting the C program based on the instructions we see in assembly. Finally, stage 3, we're getting there. It's taking me a bit more time than I would have liked or thought it would take, but we'll get there. Finally, stage 3, what is ROM? It is read-only memory. Read-only memory is, well, when you think of a Game Boy, or a Game Boy Advance or something, you have the cartridge, and the cartridge is the game, right? The cartridge is the read-only memory. In this case, we don't have a cartridge, we have a program. The exe file is the read-only memory. It is what's read and where is stored all the instructions for my program to work, and everything it needs to have to work, basically. And it is actually where the assembly is stored, the ROM is stored, and everything like that. And also there is RAM memory, which is random access memory. Random access memory being, and I talked a bit about malloc and alloc and memory allocation earlier. RAM is where all the variables are stored. For a simple example, let's say Kirby has 10 health, 10 being the maximum health he has. He can't get any more health than that. His max HP is 10, doesn't change. That usually is stored in ROM, while his current health, which is 5, 4, 7, 8, it goes up and down, it is constantly changing. That's in RAM, random access memory, because that changes. That is not read-only. You can override that. You can override Kirby's health to change it. What is the CPU? Well, the CPU is bare metal. It is the actual hardware we are using to process each of these instructions. Depending on the CPU you have, you do get different instructions. So maybe F3OF 1E FA is add on my CPU and not on yours. And that's when you get to architectures of CPUs, x86, x64, AMD 64 actually, ARM, and various others. That is the reason why people say, hey, emulating Nintendo 64 or emulating PS2, or PS3 rather, it is very, very hard because the architecture it uses is different from the architectures modern PCs uses, and emulating one on the other is apparently very hard. I might be wrong on that, it might not be the actual reason. I don't know, I think it's that. I'm pretty sure from what I've read, it is because of that. What is emulation? Well, emulation is getting a computer and by using software, trying to emulate the bytecode readings and those step-by-step processes to read every line using software. It is actually telling my computer, hey, pretend you're a Game Boy. And you read how the Game Boy reads its own data and try to recreate that using software. And it works in like to various degrees of how difficult or how hard it is. Usually it takes a lot of learning how the CPU works to do that, and thankfully it is not extremely illegal yet to do those kind of stuff. So there's a lot of emulators now, like everywhere. Emulators don't just go, I think it's well known, I don't know, maybe there's someone watching that doesn't know. But emulators are not only video game stuff, like video game hardware is the most known form of emulation. But those really fancy fridges that have their own operating system and everything? Technically, you can emulate one of those, right? You can emulate a refrigerator CPU on your computer. Or stuff like that. And but there is very little interest in doing that, so video games is what people know it most for. Finally, what is registers? I don't think I will get into registers now. Actually, do I want to get into registers? I will. Well, CPUs have registers, right? And registers are small amounts of memory that goes in the CPU. And it is usually what we are looking for when trying to reverse engineer something. Because we can emulate the CPU, we know what is going through the CPU, and by analyzing what's going through the CPU and coming out of the CPU, basically if I have the sum 1 plus 2 on my code, I know this, like the function and the parameters have to enter the registers at some point. Basically, we can check out, let's say I stop my CPU at the exact moment this function is being called, right? On my registers, it will be loaded the ROM position where it's reading the code it's running. So basically the position in ROM memory where the function sum is, and then all its parameters. Yeah, and I think that's it. That is all you need to know. It is not all you need to know, but it's a basic idea of what we are doing here. So the final proposition, the final idea, the final goal of this first section of the stream our video is getting this ROM file and editing it, the hexadecimal, to try and rewrite something. Basically have our own ROM hack of our program, of this program we just made. And well, to do that, all we'll do is we'll look. So we have Kirby in the amazing texting memory, right? And if I change texting memory to say mirror 2 and compile and run again, it will say Kirby in the amazing mirror 2, right? But that's I don't wanna change stuff here because that wouldn't be a ROM hack. What I wanna do is open this file and look for the memory position where texting memory is stored. How in the world will we do that? Well, do you remember seeing something very suspicious earlier that I mentioned? Should be around here. See, we have lib64 l linux x86 64 so. Well, this is very, very suspicious. How come this data over here shows just straight up what it seems to be, you know, text? Lib as in library, 64 as CPU architecture, just says Linux or GNU and GNU again over and over again. Well, the ROM also has a quote-unquote database, right? Because Kirby's maximum health, or even Kirby's name, the text has to be stored into the ROM file. We do end up getting some, if not all, text in game. Example of text we don't get in game is whenever you name the player character, that text is not stored in ROM. Like, there is no way for the developers to know what's the name you're gonna input, right? That goes in RAM. And there are functions to create the name and then save it somewhere, doesn't really matter. So not every text is, but most text is. So what we'll do is actually Ctrl F to find text. And, well, most of the text here is just straight up saved in ROM. If we look for mirror, weirdly enough, we get mirror here. And then my sum's value is %d. And then Kirby Amazing Mirror %s. Right? So we do have text in ROM. And thankfully, or conveniently, I'd rather say, my text, which is Kirby backwards with a dot on the end, is the exact amount of characters mirror is. How convenient. This, well, my editor here lets me just paste stuff over, and I'll just replace the characters that say mirror. So we have these characters over here, these guys, you can see it's highlighted. And if I go to 4D and just paste it, it asks how much I want to paste it, and the base, I'll just paste it over here. And we'll save the file, okay? So if I run again, and mind you, I am not compiling, right? This ROM, see, it still says mirror there. I am not compiling it. I'm just changing the final executable. If I run it again, we'll have Kirby and the Amazing Hybrid. Very cool. Very, very cool, chat. Well, this should be enough for us to know what we're doing and what we, at least to give us an idea of what is going on. I will now show you. Remember, I told you the bytecodes we're looking at are not actually real bytecodes, you know? So I'm gonna give you a look, we'll check a look at some real bytecodes. Hang on a minute. Okay. Ghidra only. Oof, I think it's not really clear to see. Maybe this is better. I wish. Well, whatever. I'm gonna hope for the best, and we'll pretend it's readable. All right. So this is Ghidra, right? Ghidra takes the executable file, those in hexadecimal, and it does its best to make sense of what's there. It is very hard for us humans to take a look at the hexadecimal values of bytecode and just bat an eye and say, oh, okay, this is a function, this is what it does, whatever, for various reasons. And because it is hard for us and we do software programming, it is very hard for software programming to automate that completely. So, okay. This is what bytecode looks like. It is not yet been analyzed by Ghidra, but Ghidra does have the idea of there are functions here. So this is our function main. You can see it's very, very weird. It is just one-to-one of what that hex file we were looking at goes by. See, it starts at F. Oh well, actually, let's go all the way back. It goes 75, 45 for C, and then if we go take a look back here, there on the top, can I go to the top? We'll see that we have 75, 45 for C. It is the exact same values as 7F, 45 for C. Is that the same actually? It is 7F. Okay, it is. So it makes sense, right? All those guys are in here. In here where Ghidra does magic. We do have an analyzer for what we're looking for. And the analyzer will look for everything. I'd like to go to the symbol. Yeah, sure. We'll take a look at the whole code and try its best to transform it to C program again. Oh, hi, Bacchus. Ahoy. Getting hit by a bot. Bot says, are you single? No. Sorry, bot. Maybe next time. I did not even pay attention to that. But thank you. So we basically analyze the code, and would you look at that? The numbers that it was really hard for us to understand now have a meaning. It basically gets the hexadecimals. Look at the CPU. The executable was compiled in, and says, "Hey, this hexadecimal value is an instruction, and this instruction it is more easily readable in human or for humans as push. We have push, move, subtract, move, load." Load EA, I forget what EA stands for, or I think it's partial load. And would you look at that, it also has the word mirror in it, the word we put in the program. Huh, isn't that cool? And when we get... Okay, so basically it is transforming into readable assembly, and then on the right, it automatically, or it does its best to automatically transform that function into C code again. Can I? Yeah, I can. I'll try to make as big as it can get without screwing up my setup. Now would you look at that? We have undefined a main void. Huh. It's a bit different from what we had. And then we go uint, which means unsigned integer, and the variable uvar1. Uvar1 receives the value of the function sum with the parameters 1 and 2. I'll just go back to my code for a second. And it is actually very different from my code. I don't have the texting memory, I don't have my integer 97, I don't have my character A. All I do have is sum. And my sum is not actually called my sum. It is called... let's check again. It is being called uvar1. Well, here comes the bummer. If it was that easy to decompilate stuff, it would be a button click and we would have everything decompilated. Unfortunately, it is not like that. We do lose a lot of information, or a lot of information is not even stored properly, and what information we lose and what we don't lose depends on how much the compiler optimizes our code or doesn't optimize our code, and also for which architecture we are compiling to or decompiling from. One of the things that will be very, very easy for us to decompile or read even is that very simple function I did called sum, which returns an integer, has parameter 1 and 2, and returns that parameter 1 and 2. I will decompile it, or quote-unquote decompile it, right? Because it's already pretty decompiled. The only thing I would do is rename parameter 1 for x and parameter 2 for y. And there we have it. This is technically a decompilation of my own program. You can see it is one-to-one to the function sum. The function sum we have over here. Funny enough, actually, it is not a one-to-one technically, because x and y positions are reversed. But that doesn't really matter. It is the actual same results, and everything else should be good. I made it on 5 minutes late. Yes, thank you. Welcome, Serenade. With this, unfortunately, I mean, it's not gonna be a problem to you, but with this, we're over the tutorial, or the concept, which I thought it would take me around 20 minutes, it took me 45. Yeah, I actually am going to do a 5 minutes break, because I will start opening the project and getting everything set up for us to decompile actual Kirby and the Amazing Mirror functions. We'll actually have to play the game a bit to find something to do, or to find... I'll go over the idea of what to do when it comes to the compilation of a program that is running. We'll have to find a target, basically, to try and decompile, or something to start from, because as we've seen, it is very, very hard to just open a hexadecimal and start doing stuff. That's a big no-go, unless it's really simple stuff like sum. But the architecture for a Game Boy Advance game, it is different, and we're not even gonna get the names of the functions. We'll see that, but I do need to take a 5-minute break to just drink water and get everything set up. I'll be right back. I'm back. Hello, hello, hello. Actually, hang on a minute, because my screen is a bit of a mess. Because, as you can see, there's a lot of stuff going on. I'll get the hang of it, hang on. Okay. Let me see if it's good enough. Oh, I can make this larger. And we do have a debugger, a memory viewer, memory search, and the GBA decompiler. And then I have my notes up there, just so we don't forget anything in case we do want to keep notes. Alright, so what's going on my screen? Well, the memory viewer, it is very much like the... Oh, that's whack, it ate my message. Oh no, what did you send? I should move to live chat as well. If YouTube is acting up, you can send me, or send a direct message or something. So what's going on? We do have a lot of stuff on screen. I'll explain each and every one of them. You can see I'll start with the memory viewer. It is on the bottom left. The memory viewer is very much like what we've seen with my own program, own compiled program. There is a lot of data there, and it works both for ROM and RAM, meaning if there is memory available for the Game Boy we are emulating, or the Game Boy Advance we're emulating, it is there. It will be readable. That's where we'll find stuff like Kirby's frames of animation, his attack, his transformation, the enemies on screen, and everything else. Also, we can get I think we can get ROM in there as well. I think the stuff like words and strings we have for the ROM, basically our quote-unquote database, will be all available there. I had asked if you ever watched Displaced Gamers. No, I haven't ever watched Displaced Gamers. It is a YouTube channel, it is a program, what is it? Also, I want to finish my thoughts here before I start responding to comments, sorry. Just so I don't lose myself. The up left, we have memory search. What is memory search? It searches the memory. Okay, fucking genius, right? But it has a very fun thing that is one of the buttons, means it goes search within. If we're looking for a specific value we know, let's say for example Kirby's amount of lives, or his current health, which is, we'll say 6 out of 10 for example. If I look up 6 and then Kirby's, I get a list of all memory, of all the memory which has 6 stored in it. So basically a memory is, it is divided in blocks, usually 8-bit blocks or bytes, and we look for or 16, 32, really depends on the, I think it's architecture, it depends on. But it has a default amount. We'll look for all bytes that have 6 in them, or how big is the variable as well. Well, I'll not get into that right now. It looks for 6 in the whole Game Boy memory. and it gets me a list of all 6s. If I drop Kirby's health to 4, I can look for 4, but Kirby's health is static in the memory. So I will look within all 6s I've looked before, I will look for a 4. And then I can start filtering all the memory that is most likely to be Kirby's health. Until we find it, or until we have enough contenders that is easily, you know, you can easily go through them and start messing with them. And that's how that's the logic we'll use to try and find something we can mess with, which, come to think of it, I think when it comes to Kirby, that's probably the best thing to do, is his health or amount of lives left, because it should be a number, right? The number you get is the number on memory. It starts getting difficult when you don't have a starting point. If the game doesn't give you actual values or actual numbers, and you have to start guessing what that number might or might not be and how much it goes up and down, you start getting fucked, basically. It is very, very hard to you know, get a starting point. And once you know Kirby's memory, right, Kirby's health, right, that memory, that where is it stored, we can use the debugger. What does the debugger do? Well, the debugger is a tool that has several different functions. We'll go help here and we'll read them. Not all of them, just a few. A few we'll be using is what is watch. We'll be using watch a lot, hopefully, if we can get more than one function done. Sets a watch point. What is a read or write or change watch point? Well, the RAM and the ROM both are just memory, right? So we can basically set a watch point to Kirby's health when it changes, so the game freezes. The moment Kirby's health changes, the game freezes. And the debugger lets me see what's on the registers, what's on the CPU, including memory space. So let's say we have a function that changes. We'll drink soda, right? Kirby has low health and he drinks soda, and his health was 4 and now it's 6. There is a function that adds or subtracts to Kirby's health, or there is a function that adds and another one that subtracts. I don't actually know, but there is a function that does that. If we set a watch point to Kirby's health, knowing its location in memory, and say, hey, when this changes, stop. When Kirby gets the soda, the code that heals Kirby will trigger our watch point, and the code will stop, giving us the memory the CPU was reading at the time. How does that help us? Well, we know it's a function that heals Kirby, and we know its placement. So we now know, like in memory, where is Kirby's heal function, right? And then we'll go there and we'll see if it all works out, if I'm not bullshitting you, because I'm really going... I'm just rambling at this point. I don't actually know these things, because I haven't... Well, I've done this before, but not with Kirby, so it might work differently. I don't know, I'm still new to this. But hopefully we'll find Kirby's healing function. And from there, we'll reverse engineer it. And finally, Ghidra will help us with the reverse engineering, which, by the way, I will analyze Kirby in the Amazing Mirror, so it doesn't really go all hexadecimalness, and we actually get bytecodes. I will now read chat, sorry for the delay. It is a channel. He goes over how old games were programmed using memory viewer in his emulator of choice, and creates game genie codes for viewers to go and modify the games themselves. That is very, very cool. That is super cool, actually. I'll probably check it out. A lot of times he does deep dives into NES games and that barely works, and introduce game genies to make them work. That is super cool. See, one of the things that really started my interest in maybe I'll check out how this silly stuff works, is people who went back and fixed the bugs on Final Fantasy VI, because it has a lot of bugs. One of them, which I find hilarious, is blind doesn't actually work. The only thing it does, it gives you a like your character cool shades, because you get those dark shades when you get blind in the game. So there was no actual reason to care for blind, besides the cool shades, and someone fixed it. The SNES version of Final Fantasy VI, you can get a patch that fixes the bug, which now your character gets shades and is blind. So you tell me if that's a plus or a negative. Well, you can see on the bottom left there is a bar going haywire, basically telling us the program is being decompiled. And let me see if you can see that. Yeah, you can see the orange, these orange lines are appearing. They're basically functions and everything else. Well, part of doing this kind of stuff is we actually get to play the game. To do the reverse engineering. My game freeze. Oh, my game is frozen because of Ghidra, I think. Where's the debugger? Let me see if we can continue. Oh yeah, it was the debugger. Shoutouts to the CIA. Yes, Ghidra is not CIA. I think it's NAS, NSA. I'm pretty sure. Unless they are both CIAs, like it is a CIA thing. It is Ghidra. It is actually developed by the the Alphabet Gang. Yes, it is the Alphabet Gang. And Ghidra is developed by the United States, so you know. There's a very... Oh, how convenient. Okay, so we do have a soda right here. And I'm gonna have... Okay, hang on. I'm gonna actually make this larger so I can see. Did it make it larger? Actually, that's too large. Did it also make larger for you guys? Yes, it did. Hang on. I'm gonna hide the emulation stuff because I don't know, it's ugly. So let's see how many. Okay? Fuck you. So Kirby has 1, 2, 3, 1, 2, 3, 4. Oh my god, I'm blind. I gotta get my mouse. 1, 2, 3, 4, 5, 6 total health, right? And I do have 5 current HP. So I'm not really sure if this is gonna work out again. I just want to be clear that I'm going in this blind, so if it doesn't work out, don't blame me. We'll do a new search for 5. We have a fucking shit ton of values with 5. We'll try and hurt Kirby a bit more. We have now 4. Oh shit. We have 5 again because I healed. No. Okay, we have 4. Leave me alone. 3. Okay, 3 is good. We do have a new value, right? So we have a list of the positions where 5 is a value in a byte. And now we're going to go search for within those values for 3. And we have already nailed down basically. It's looking good. I'm gonna save. How do I save state? Shift F10 and then load F10. Okay, I'm gonna save. I'm gonna save and get the healing. Healing puts me back at 5. Search within. Okay, so one of the quirks, I'm pretty sure this is Kirby's health. We'll check out in a bit. We get 4 values. You can see it's doubled. The first and the second value are the same address, and the third and the fourth are the same address as well. If you ask me, I have absolutely no fucking idea why this is. The one thing I do know why it is, there are 4 values. Like, let's ignore the doubled values, right? We get basically 2 values, 2 addresses. The reason why is... It's fantastic because my next phrase is gonna be, I don't know why, and then I'm gonna explain, but the reason why is, I don't know why the Game Boy has memory, like he has part of his memory, or of its memory, is specifically to duplicate another part of the memory, right? So I don't think we're ever gonna get less than, we'll get a single value. I'm pretty sure 03 is the part of the memory it is used to duplicate. So we're looking at this is 02, what was it again? 0202. So 02, it is WRAM, onboard work RAM. We have 256 kilobytes of RAM, and Kirby's health is probably stored there. Let's take a look in our memory viewer. OX 0202 OFE0. Right, we have 0202 OFE0 here with 5. If I try and make it 6, oh shit, Kirby's health healed. Okay, that's super cool. And if I do, I don't know, 2, it goes... Yeah, we're almost dead. Can I kill Kirby this way? I wonder. Just for fun. Let's check it out. Yep, I can kill Kirby. Fantastic. We have Kirby's health in memory, right? That's super cool. That's fantastic. Okay, I'm just gonna take a note of the address. It is this one. We'll have Kirby's health. And then format. Perfect. We'll do OX. That's super cool. Holy fuck, that's super cool. Okay. Now, what we should be doing is getting the debugger, which I have it right here, and going, hey debugger, do me a watch. Watch for change, and then the memory, which I have on my notes. This guy. Oh, I don't want to break actually. See, and bam, we have added a watch point, right? And okay, So we were watching for changes in Kirby's health. What should happen here is I'm gonna get hit by Wheel Guy, Wheelie, or whatever his name is, and the emulation should come to a halt. And we're gonna get some output on our debugger. Yep, it halted. All right. Although, oh yeah, we did get stuff here. See, we hit watch point 1 at Kirby's health. New value is 5 and old value is 6, so we lost 1 HP. You can see it is not yet changed Kirby's HP because the game hasn't rendered the next frame yet. Next up, we are gonna talk about registers. So registers are that thing on the CPU that basically allows us to load only the minimum amount of we'll load the instruction, not the instructions, sorry. We'll load the parameters, the minimum amount of parameters, memory. We are loading the actual memory that is in our random access memory, our RAM, and we're loading what we need on the CPU. I might be wrong, right? I'm starting to talk about things I don't know. But I think this is considered a cycle, and if you have to get more memory, it might be another cycle. I don't actually know. It's getting too specific. I don't know, maybe I should have been saying stuff I don't know. Look it up. I don't know. Well, we do have 4 main registers, which are R0 through R3. We can see the values for them, which is 5, 2020 FE0, 6, and then 02000144. Huh. If you're an astute person, or you're paying attention, or even if you're not, I don't know, you can see that R0 is 5, and then we have Kirby's memory, and then we have 6. These 4 first registers, only them are used for parameters in a function. All the other ones are can be used as local variables, or if you need more local variables than that, you can use the heap memory. But you can see that we are basically looking at Kirby's old value, and then Kirby's health, and then sorry, I hit the microphone. And then the next the new value, Kirby's health, and old value are the 3 parameters we're getting. We can see the cycle number on the debugger as well. Also, I moved the debugger. I don't know if that's... Yeah, you can still read that. We can get the CPSR, which I have absolutely no clue what it means. And finally, we get the position and exactly the bytecode or the assembly line that changed Kirby's health. So what we do now is we have the position where Kirby health was changed. So we'll go to GBA and we'll look for that for the ROM memory. ROM memory. Yeah, we'll look for the ROM memory, which has the function to heal Kirby, or to damage Kirby, rather. And holy shit, it is way bigger than I expected. Huh. Hang on, I'm gonna make this easier for me to read. Oh my god. Huh. If I had to guess... if I had to guess, this function hurts an entity and not Kirby in particular. Because the second register at that point is Kirby's health. Right, should it be Kirby's health? Hang on, let me think for a second. Huh, okay. Yeah, I'm not doing this. Well, change of plans. We're not hurting Kirby anymore. We'll probably try and heal him and see if we can get something that is less scary. Because I don't want to waste a bunch of time and give up on something. I want to find something simple to do. That's as honest as it gets. Disassemble, watch, trace symbol. I want to delete watch point. I'm gonna delete one. Continue. Okay, we're gonna try and heal Kirby and see if the healing function is simpler. Do we get that? Oh, no, we don't. I need to try and find something to heal Kirby with. Which, by the way, I think I do have. I did load state. Okay, so I do have it. Okay. Oh no, actually I do want to keep that watch point. I'm gonna keep the watch point, and we'll see if healing Kirby should also trigger it. Yep. Okay. Let's take a look at that. Old value 3, new value 4, so we had 3 health and we're gonna have 4 health now, and this is... Wait, oh no, sorry, this is Kirby's health position. This is our heal Kirby function. Oh no, it's the same function. It's one to do... Okay, so it's one function to both heal and hurt Kirby. Oh shit. So it's 08, 04, 89. This one is 08, 04. No, it's a different one. No, it's not. Fuck. They're gonna hit you with the oldest trick in the book where healing just runs the hurt function backwards. Yeah, I'm really thinking that's the case. Or with negative numbers. Not backwards. It's probably one thing. I wonder if it maybe just skips. It probably checks if it's not Kirby. It doesn't really heal. Well, I know something else we can try and do. We'll continue. We'll look for 2. Oh, hang on, continue. Did I delete my watch points? I don't think I deleted my watch points. Delete a breakpoint or watch point. Argument missing. Oh, I do have to give them the... and then... Okay. We'll try and see... we'll try and see if we can find Kirby's continues or health. Not current health, just lives. But for that, we'll have to kill Kirby over and over again. Let's see if we can do that. Did I not delete them? Oh no. D1, D2, D0 maybe? D0. Okay, it's D0. No, I killed Kirby. Bam. Search within. Kirby killing stream, yeah. The guy didn't see it coming. For 0. Oh no, we still have a lot of hits. We might have to kill him and start over with 3 again. Which, random thought. It's always an issue for me to try and understand its life remaining, or how many like lives left you have, extra lives left you have, or how many lives you have. 2 again. Search within. We're getting there. I think I might just... Well, I'll kill him just once more, and I think we'll have enough. We'll just check out the memories one by one. And if I fail, I'll probably try not to not waste time, quote unquote, but you know, do something. Oh yeah, no, okay. All these memories are changing together. We'll try and make this logical. So they are all loaded in the same part of memory except this one. So this one is definitely not it. I'm gonna try and give Kirby 4 lives maybe. On, well, 2 and 3. This one are right next to each other for some reason. We'll go over to F2, which is this one. Well, I mean, this is Kirby's health, right? Usually, if I had to guess which one is Kirby's amount of lives, it would be this one for sure. Mostly because Kirby itself is probably a big structure of all the different status it has. And the way structures are loaded into memory is it is loaded in chunks. So most likely, well, we'll see. I'm gonna move Kirby and something's gonna change, because somewhere around here is Kirby's position. This one is definitely Kirby's animation. If he's walking left or right. So every time I go left is 20, every time I go right is 10. Look up 4 and going down 8. I don't see... Oh, there's too much going on now. Well, anyway, I'm gonna try and change this value. We'll do 4 and we'll see if Kirby lives go to 4. It does go to 4. Came here to full expectation of watching time get wasted and I'll get retreated several times. Don't worry, I will last. I'm good. I mean, see, well, although this is very, very, very like I'm starting something that I have no idea what I'm doing. Basically, the setup, what would be the setup of a project in decompilation. My idea is if I'm gonna waste time, I'm gonna waste time trying to do like actual work. I found a Kirby in the Amazing Mirror decompilation project, which already has progress in it, and I do not have to quote unquote waste time with trying to go over steps other people already have gone through. So if I'm gonna waste time, I'll probably open that project and I'll actually try and do actual work that, you know, that can be used. And I'll have to create a GitHub to not get sued by Nintendo in the future where the compilation is forbidden or illegal. Okay, we do know where Kirby's lives are in memory. We'll set a watch point for change in 0202 OFE 002 actually. Command not found. It is not watch, maybe it's watch change. Yeah, okay. Okay, now we're gonna have to find a 1-up. Or die, actually. We can die. We'll die. If I had to guess, the function that adds and removes to Kirby's health is also just like the function to heal him and hurt him, which is the same function, but with negative values. It is, I don't know, it's kind of a smart way to do it when you think of it and you have limited resources. There we go. I wrote it myself, officer, I swear. I'm gonna have to set up a just like a dolphin team. I don't know if you know how Dolphin develops the Dolphin emulator for GameCube and Wii. It is 2 teams. One has to read the leaked documentation and then explain to the other team what the function does, but not exactly like line by line, because that's illegal. Just like the idea of what the function does, so they don't get sued. It is very, very sad. So let's go to OX over here. And of course, it is also... It is not the same function. But it's not simple either. Ha! How come? Well, you know what? We'll give it a shot. Before giving up, you know, because who knows? It might not be that awful. Although I have a feeling it'll be very, very awful. Not crazy, am I? This is not the same function as before. Am I doing something wrong? Watch point 2. Oh wait, 1. No, no shot. It's not the same one. Okay. So, fuck. See, the idea was to have a simple function. But what we... Okay, I'm gonna go through what we get here. Because if I can't do anything, I think I can at least... get the idea. Local variables, we have a parameter which is a byte position in memory, which is probably the structure for Kirby. Why I say that? Because it is... the function is using sum to change its position. So this is for sure edit function signature, not signature, variable. Kirby Kirby pointer, right? So what I'm getting at is Kirby's position plus 8, which is some variable inside Kirby's structure. The result that is an integer, and it receives the integer, the same guy, or 3 or 4. Huh. This is to do by bit comparison. It's an OR. I'm defining for pointer, Kirby pointer. It calls the function since Kirby. If it's Kirby, maybe it's not. Maybe I'm jumping the gun. But it's a structure for sure. It is not Kirby pointer. Well, I mean, you can be just checking. I'm gonna check out this function. Copy. What is it? Maybe you can get a... Oh, I think this is a start function. Just create something. Oh, I'm going back. I'm gonna leave this a pointer actually. Rename variable. We'll do var pointer. Can I highlight everything? How do I highlight it? Okay, got it. It's gonna be hard for you guys to see, but I gotta make it better for me to see. There is no position O3, O3, AD, 3C. Two, three, four, five, six, seven, 8. Oh. Maybe time to contribute nothing of value because I don't understand what's going on at all. Yeah, it's okay. I don't either. I was expecting this to go way, way smoother. It is not. I wonder if I, so... So this is... just make sure I'm on the right thing. X here. Function for this guy. It's this one, right? So this should be. I'm just gonna rename this to life. This life function. And then I get a pointer. So this pointer. Oh, that's in registry. Actually, you know what we're gonna do is we know exactly. Oh, see, okay, I know what we're gonna do. Okay, so this guy is. This guy is... Oh, actually, no. Let me think, hang on. Does he have a memory address to him? I think he should. It should. Maybe we can use this one. 8, 9, 10, A, B, C. Yeah, well, it's this one. So we were watching for a value to change in Kirby's life, and we found out its function, right? There is a way to know what are the parameters for that function. We stopped at the middle of the function. We should actually now now that we know where the function is, we should stop at top of the function. Because the moment the function is called, R0 is, I'm 99% sure, R0 will be a address to return to. So the address that called the function live function will be R0, and R1 I most certainly will be our character pointer over here. Let's check it out. We'll see if I'm right or wrong. Hopefully I am right. We'll delete watch point 3 and watch. Actually, no, it's D. Okay. We'll watch for the program when it's reading when the CPU is reading the instructions for the first line of the function. We'll do that, and then we'll have to kill Kirby again. One more HP, and we did not. The game did not freeze. Why? It did now? Wait, what? Oh, it's okay, it's freezing because I'm giving the command to delete. This is live function. Am I wrong this whole time? Am I looking at wrong code? I think I might. I definitely am. Or did I copy wrong? I don't think I did. What are my watch points? Help. Pinch events, once events. Oh no, that's not what I want. Backtrace, break, continue, delete, read, set status, symbol trace. Set breakpoint in ARM. Do I want that? Do I want a breakpoint? I might want a breakpoint. Let me see if I want a breakpoint. I might want a breakpoint. I did breakpoint 5. Let's check that out. Get Kirby down shape, peg of health, and quick save. Or save state, rather. Okay, maybe I do want a breakpoint and not a watch point. Let's check it out. Okay. The first thing I want to see is I want to go to my register 0 and noticed it doesn't exist. Maybe register 0 is just the function. Watch point. 4. We're definitely stopping here. Oh, I'm dumb. Okay, hang on. Can I Control Z? No. What was it called? Edit function signature? No. Name function. Can I? No. Oh no, I'm dumb. I renamed the. Can I? Oh no. Hang on. Continue anyway. Yes. Don't save. I forgot the function name. It is actually func underscore and then its memory space. And I messed that up by changing its name. We'll check it out. At least I know where it is now. We'll check it out, and if I'm able to progress or find something out that I didn't know before, we'll continue. If not, then it's been almost an hour, or it's been an hour. I might just set up the actual project, because doing reverse engineering when you already have a project set it up, it is, I'd say, more straightforward, right? Or at least it doesn't require this many tools to find stuff out. And I'll just set up the actual project, and maybe I don't know, I'll try. At least if I'm at the project, I don't feel like I'm wasting time, because even if I am, sooner or later I'll figure something out. But I do intend on just streaming until I get bored, which is probably not gonna happen soon. Just beware. You're in for a scare. I think I'm just gonna turn this into a normal stream at this point, instead of explaining everything I do. I'm gonna fucking talk about stuff that media I've been consuming, and quote unquote culture. I watched the Five Nights at Freddy's movie, or at least half of it. I've mentioned before that it is a very, what is it called, morbid curiosity kind of deal. Oh fuck, it is the first one. 0104, 0804, FB, FC, BFC. Damn, I'm just dumb. Okay. It is the most boring movie I've ever saw in my life. I understand I'm not the target audience, like, but it is so unbearably boring. I could not bring myself to watch the whole thing. It's not fun bad. It's not fun. Just bad. It's morbing time, kind of like that. I still don't get it, and that's what makes me like the most confused. That's what thing scratches or itches the most in my brain, is that I don't get it. I wish I did. I thought like maybe the movie is a nice way to what's 2020 E0 2020 EE 0. I don't get it. This is definitely where the code was supposed to be coming from. And then our one is just empty. It's just empty. What can I print? Print value as we do P and do P and then this one. It's just a no pointer. This is what I don't get. Parameter 1. Wait, parameter. Oh yeah, parameter 1. It can't be R1. Because this would be writing into nothing. So it should be this one. This is the value. Print X maybe. Okay. Actually, never mind. I'm done. I forgot what I was talking about. I don't know. Morbius was actually so bad it was funny. I did not watch that one, to be honest. Most of the movies that come out, and it's like it's so bad. Hollywood did a mistake. I'm usually somewhat curious. I do at some point in my life want to watch that one Ghostbusters movie. Reboot, the all-female Ghostbusters. I do want to watch that out of curiosity. Which again, it has the Star Wars infamy of it has more bad movies. Like there is only one good movie as far as I know, Ghostbusters movie, which is the first one. Even the second one is awful. It is not fun. I don't get it. I don't get why or how it's such a big deal. As a series, I don't know. There was a lot that was boring. It was like watching ChatGPT write a movie, or whoever wrote Rogue Galaxy or Grandia 3. Oh no, they had access to AI all those years back. It was AI generated. Let me think for a second, hang on. Let me see in what part of the memory. I don't get it. Maybe I jumped the gun. Maybe I should have done more stuff instead of trying to come in blind. Yeah, you know what? Instead of just going round and round, I think I'm just gonna set up the actual project and see if that's any easier. If it's not any easier and I'm still just fucking bumbling around and having no idea what I'm doing, which might be a possibility. I'll just fucking end stream and, I don't know, learn more, I guess. Study more before coming back. Because it is something I wanna do. I really wanted to do one function. But the problem is there isn't really a good... I can't... I'm gonna email Sakamoshi, or what's the Smash Bros guy? I'm gonna email him. Hey, where do I begin? Decompiling Kirby and the Amazing Earth. Give me an easy function, please. Sakurai. Yeah, I'm gonna do that. Hang on. I'm gonna hide everything for a bit. And I'm gonna do the comp, yes, the code comp, only this one will be Kirby decomp. Add window, we do I want this one. Funny, not funny, I guess. But the project I'll be trying to do progress in doesn't really require me to have the Game Boy open or do anything in there. I'm gonna show you what it's like, and I'm gonna read the instructions on how to... I'm gonna read it again because I already read it. I'm gonna read again the instructions on how to contribute, and it is very straightforward on how to do stuff. Which, I don't know, hopefully it ends up being fruitful. Oh, hang on, I'll be right back actually. I'm back. Apparently we get something, but he should be back in a minute. I think he likes stuff a lot. Well, I'll wait for him, because I do want to get more water for myself and maybe some tea. I wish I knew anything to say this stuff. This flies over my head. Don't worry about it. It doesn't really matter. I don't have anything to say as well because I don't know what I'm doing. That's honestly, that is as simple as it gets. Although I will say, having the project set it up is way easier. At least I'd say this And I'm sure I'm not gonna be able to do anything. So maybe I shouldn't. Maybe I shouldn't say stuff like that. I'll fix the. Maybe that looks better in widescreen. And I'm gonna one more thing. Properties. This guy. Then I'm gonna crop bottom. No, crop top. Nope. More. Yep. Nope. Too much. This should be good enough. Actually, I'll play safe. And then do 500. This one do 300 maybe. A little more. Yeah, that's good enough. Leave it here. Well, I'm gonna do a small break then. An actual small break. When Serenade gets back. I have zero problem just waiting. I'm gonna get myself some water and some more tea. I will say, I'm back, by the way. I will say, even if I make zero progress whatsoever, I think it's still been fun. I don't know. I like kind of doing this stuff, which just messing around. It is what I would like to do more often, although it is very, very hard to find a career in this, I guess. I don't know. It's obviously for fun, right? Like, it's games and not actual software. I bet like reverse engineering software has its place in the economy and everything else. But even if I make zero progress today, I still am very, very interested in doing this in my own time. And hopefully if I get the hang of it, which for now I plan on doing so. I had a bunch of projects up until recently. I like working on stuff that's not work. To not be crazy, like not turn crazy, you know? Because working is fun, but if I only work on one stuff, and if it's only like actual work, I don't know, it kind of grinds you down. You gotta do different kind of stuff as well. Learning is fun. Yeah, well, hopefully, not hopefully, fortunately I did finish a bunch of the stuff I was doing in parallel. And for the longest time, I wanted to do reverse engineering stuff, especially Game Boy Advance. I think there's various fun games we have on the GBA console that could use a different or a better version of themselves. It is the golden era for weird or not weird, fun, different, very unstandard multiplayer connectivity. A lot of the stuff follow the Pokemon steps of trading and battling, but there are a few games, Kirby and the Amazing Mirror included, that have really captivated me for a long time. And unfortunately, the only way of playing them is through actually getting people together, because I don't think there is a way of emulating Game Boy connectivity. It just doesn't work. I know the Dolphin team has been doing like good progress in the GBA to Dolphin connectivity. I know MGBA, the emulator I was using, does do a lot of the GBA to GameCube connectivity. But I don't know. I just wish there was another way. And I guess reverse engineering kind of does that. Sorry, I didn't know I was being wanted on. Waited even. It's okay. Wanted to test out some paint too. I just waited because Sven said you were coming back. So I'm gonna start the next step, basically, which is the actual project. People have already removed all the functions and have separated them into files, which is very, very convenient for us. These are the basically the contributing markdown on the GitHub page. They are following. It is not for their GitHub, but they follow the same process. Is code starts out in ASM or ASM folder. When decompiled to C, it goes into source, and the goal is to decompile all code. Some code in ASM is handwritten assembly. It can't and shouldn't be decompiled. it's already commented, so there is no further work to do on these files. And then it just names a few files, which doesn't mean anything to us because it's not our case. This is the same contribution tutorial for another project, basically. The rest of the .s files in ASM are fair game. The basic decompilation process is the file that goes in ASM, i.e. asmax.s. You create a C file called source/x.c. So basically get a .s and then create a .c out of it and move folders. Translate the first function to C from one to another. Make and tweak the functions until it matches. So one of the fun things that is done is I extracted legally my ROM from my Game Boy game, and it is basically the final product, right? And then their make file for this project also creates a .gba file, and it's compared to see if the function that was written is being compiled one-to-one with the function in assembly. So basically recreate the function assembly in C and try to compile it, compare. If it's one-to-one, fantastic, we just decompiled a assembly to C. What a law-abiding citizen, yes. Please do not arrest me, I don't want to pay an allowance to Nintendo for the rest of my life. Also, do not go to vimm.net. Vim.net is an incredibly illegal website, do not go there. You can find all the ROMs and illegally download them there. Not cool at all. Someone has to shut down vimm.net. This cannot continue until vim.net with 2 M's, VIMM, is down in the dirt. Because it's very, very illegal and not cool. Nintendo is losing their money. Okay, going back. So we have a global which basically has a lot of structures. When we do want to compile, we add source in the text, the object file generated from C to the make file, and then it just helps us to translate a function. Fantastic. Here we go again. To fail miserably. So this is the project. We'll see it's very, very alike what the that contributing markdown was teaching us. We have an ASM folder and a source folder. We can see that let's take for example cutscene trigger.s. We have a cutscene trigger. Cutscene trigger. Nope, we don't. So cutscene triggers have not been translated yet. I have checked out. I will not be doing this one. I have checked out Flamers. Flamers is the meteor enemy. The one guy that has 4. It's an eye and he's pink and he has 4 flames, and then he starts turning, becomes a meteor, and just attacks. So flamer.s, and then we have flamer. Where is it? Flamer.c. Yeah. Do you not? Are you not configured correctly? I will not configure this correctly. Okay, fuck that. Okay. There are... I've seen a function that is not currently decompiled in flamers.s. So we'll try and help and decompile the function here. Create flamer. Okay, so they already. This is not a. What is it called? Declarations. This is just a list of functions that haven't been decompiled yet. Yep. Okay. So this is the function. Pretty big, but I think we can start little by little. I'm just gonna do arm for being. Being a Vim with two M's, yes, Vim with two M's. Not cool Vim. The first function we have is push, so let's check out if we have push on the documentations. Push pop, push registers onto stack. Can I wish I could... Oh well. You guys are not gonna see the documentation for... Actually, I want to have that here. Yeah, should be good enough. Push registers onto stack. So we have push and then a list of registers. So we basically have, let's see, U8. How large are the registers actually? Game Boy Advance register. Four bytes. You wait. Let me check out. We have another one here. Really don't rename it. Oh well. R4, 5, R6, R7, LR. Move. Let's see what move this. These move are 7 SL. It's basically a load, I think. So R7 takes a cell, 16, Politics R8, which is not. It's not created. No, it pushes into the stack actually. I think this might be parameters. Oh, my bad. I forgot to check out chat. Nightmare. I guess that's music. I actually am really off with music, remembering music in general. Minus points for Nightmare in Dream Lane though. Yeah, I'm just paying attention to seeing what I can do. See if Ghidra helps me a bit. Okay, I'm disassembling some stuff. Remembering music's like Serenade's superpower. If he heard it before, he remembers like 99% of the time. I can tell what version it is. What game is it from? Near the game. Can you... I've heard... I don't know how true that is, but I've heard there's people who can recall smells from the music they hear. I don't know if that's Serenade's situation. But I think that's interesting. I don't know how that works. I think like probably some people have some wires crossed in their head. But it's I think it's a funny thing that exists. Or I think it exists at least. I have a feeling that I've heard this before, and that's what I'm saying. Both Doge, Serenade remembers music, guitar Doge, Serenade making music. Never tried. I don't know. I making music is kind of cool. I have never done it myself. I think it could be cool. Five, six, seven, eight, nine, 10, 12. I don't know, this kind of sounds like Yoshi's, Yoshi's Island or something, or 64. Yeah, kinda experiencing his total recall of music for a while. I believe there are people out there that have like that. The first smell. Or taste or whatever other sense. No, I mean people that remember smells based on sounds or musics they hear. I'm gonna look this up. I'm pretty sure there's a thing. people remembering smells based on music. Or maybe it's just a normal thing that normal people have, as normal humans have. This phenomenon is called synesthesia. It refers to the way certain people perceive reality differently, specifically this condition wherein it triggers one's senses, where one sense, in this case your hearing, can trigger another sense simultaneously, such as smell or taste. So there's people that probably can taste or reminisce of tasting something because of the music they hear. There was this one guy who described the smell in some places yellow, and I sort of get that. I don't. I really don't, but I don't know. Sounds kind of cool actually, when I mean, I guess not for everyone. See, I am scared of this one. I'm gonna give up on this one for now. I'm gonna try and look for specifically one that I look at it and I feel like I can do something about it. It's just this one. I think this one's a small one, isn't it? G. PDD. Yeah. Oh, it really is just this. I guess I'll take a look. So it's calling it LDR. Let me check what LDR is. Load LDR. Oops. Load immediate offset. Word half of a byte. It's what? LDR. To register. It doesn't have an... Oh, it does have a register offset. Oh no, it doesn't. It's an immediate value, I guess. Yeah. Forget it. Taste and smell seems very linked, but sound is a bit further away maybe. I still think I understand though, connections like that. To think about the church I went to preschool at, I can remember the smell of the cafeteria, but that's probably not similar. Do it smell yellow? Well, the floor was brown and it was really shiny, so I gave the room an orange tint. It isn't fair to say it smelled orange. How shiny? That has to be really shiny to give the room an orange tint. Or maybe the orange tint wasn't as strong as I'm inclined to think. Or not inclined, just thinking in general. Let's check it once again. So, this guy. we push the stack. I mean, nope, that's not what I want, actually. I just want this guy. What have you forced? Do I know? Only you wait. It's LDR. LR. Push LR. The link register LR is used to hold an address to which a function should return when it finishes. The BL instruction essentially is a call. I don't think I need to push LR in C. I think it does that by itself. Oh, we'll just ignore that for now. So we have add register 2, which I still am not sure if I should be changing the parameters on this or not. For now, I'm not going to. We'll just create a variable R2, and if I need to, then I'll move. I'm pretty sure this. Well. Adds R2 are okay, so we'll have R2 receives R0 plus 0. I think that's it. Let me check the adds. Add. Add followed by a register, followed by a register, followed by a static value. I guess that's it. So gratuitous receipts are 0. Okay. Okay. And then all DR. All DR. Load with immediate offset. So R0 won't be done, but this is I think this is this. It is offsetting R2 by 8 and then loading it to R0. Let's see. That's right. So the arc sample. I guess that's it, but well, maybe this should be a pointer then. Maybe do this and take this one away. Moves. I think this loads. Moves. Moves are 1, 2. I think that's just R1 receives 2. Let's do some googling. Moves. Yeah, it seems that way. But we do not know what R1 is. So I'm just gonna, for now, it's just gonna be a variable. I don't know if all registers are memory. I think all registers are pointers. Maybe I should do this. Do R1. And what the fuck is an end? Just normal end. Logical end. Oh, so it's an if. It's actually R1. And I'm gonna fix that. I know it's doesn't really make sense. compare R0 to 0. If branch equal, so if I'll make it as plain readable as possible. Branch equal to this position, so this is pop, else adds. So I'm gonna do it like this, just to continue with the same logic. R0 receives R2 plus 0, forget plus 0, and then BL, it's branch. What is BL? BL. Long branch with link. And BX. Show address held in low range, high range. This is just a return. Pop R0 and then return. Else return. Oh, it actually does nothing. I see. Okay, it just skips code. I get it now. So returns. I don't know if it returns anything. I don't think it returns anything. Mostly because I'm fairly certain that what I said before is true. That R0. I don't know if it starts off or if the return value of R0 is always where the CPU should be going to. So what do we do with R0 at first? Load R0. We don't save it anywhere. What is it popping? I don't get it. Pop registers from stack. Let's see what Ghidra says. I don't think it's helping me. I was studying 6502 assembly a few months ago when I had a little time to. I've been busy not being able to continue. Sorry, I can't help you. It's alright. I've dug this hole myself. Which I don't know if I think they might work similarly, but even then I don't think they necessarily have to follow the same logic. I know BL is a function call, so it looks like we're calling this one. I don't know what it is. Do I have it here? Oh, it is the first one, right? It is the first one. I enjoy the fact that I enjoy the fact it's going on in the background. The feeling of, hey, I know that thing, but I have no idea what it is actually. Yes, I've heard of registers before. I don't know. I can't blame you. I do the exact same thing. Where you know enough that if I say something that makes sense, you're like, yeah, that seems to fit. That seems about right. Okay, so let's make sense of what's going on here. Again, these are all pointers, I think. Just change this. I don't get the ends. I'm gonna have to look this up, cause I don't know what it does. I don't think I've seen this one before. I don't know if it's actually just comparing an end or ARM wiki. Fatal error, nice. ARM wiki. Really not helping. And it's not even listed. In the instruction summary. Oh, maybe it's because it's summary. Maybe I do have a... instructions. Let's see if I can find it. And I do have a real big PDF file here with a lot of stuff. It doesn't seem to have ends on it. How many ends do I get? A lot of them. Okay. Oh, cond s, conditional s. Just, wait, hang on. Well, I mean it's make. I forget how to compare. Flamer.c. Oh yeah. I'll go back and see if I can see how it compares. Does it compare automatically? I think it does. File. Compare. compare. Okay, so I have 1 to 1, and if I change this guy, does not know, and what the why do I not find it in the instructions? I'm just gonna assume this is just an end. And the S is, I don't know what it is, but it's something. Wish I was at work because I have tons of reference sites to pull up and could link to. Local man wishes he was at work on a Sunday. Yeah, I'll accept those tomorrow if you're going to work tomorrow. I'm just gonna pretend this is an ends. And I'm gonna Control Z my way back here. Yeah, you know what? Let's see how ends work. Let's see if it makes sense either way. It is, yeah, so this is basically the same as this. Well, I mean, not the same, it is this. And the second operand is ends and then compare. Compare R1, choose 0, CMP. Compares conditional. Register and then operand. Dude, I used to be good at this. No, I'm not. I don't know if it's actually this. And then all the parameters for this one. I'm just gonna comment it for now. Oh, I mean... I am. Oh no. Wish he was at work. Wish he wasn't at work else. No, he wish he was at work. Wishes he wasn't going to work. Huh. I think I'm gonna take wait, one step back to maybe take 2 steps forward. I might just end stream for today. I'm gonna keep at it, at this function. This is gonna be the function. But I do want to... maybe just sit down and study somewhere. Or maybe try a few exercises, I don't know. I haven't done much because I was in the strong belief that I remembered what I learned about 5 years ago in uni. I don't. At least now I realize there's a few things I'm guessing. Wait. Am I decompiling the wrong function? No fucking way. Wait, hang on. Am I that dumb? I am. Which one I was decompiling? What's this one? What's the one above? C4. Which has already been decompiled. Because it's not here. No way. Oh, good news. Well, I think I might be able to see how far off I was. How do I find it? Maybe just looking for it. Should be a small function. Where is it not here? Oh, maybe it's not even here. Oh yeah, it's not even here. Okay, not awful then. Some function start. A4. I don't get it. Why is this not showing up? 58C. Oh, it's this one. Is it? Am I dumb? Am I messing up again? Oh, it's this one. Oh no, I was doing... Yeah, no, I messed up. It's not this one. It's alright. Doesn't really change anything. So 80 BA 58C 80 BA 5. Oh, it's 5C8, it's not 8C. I don't know if they messed up or I don't know now. Okay, they did not mess up. Let's see, just both of them exist. Okay. I'm gonna do that. I'm gonna stop for today because I'm doing 0 progress. This is not as straightforward as I remembered or thought it was gonna be, but it's okay. I don't plan on doing anything doing anything else besides trying to learn this shit. So sooner or later we'll see progress. Part 2. I don't know if it's gonna be there's gonna be a part 2, at least not this year. Family Christmas and family end of the year stuff is coming up sooner than expected. Most likely starting next week. I'm gonna poof out of existence. If I ever do this, if there's ever a part 2, I'm only doing part 2 after I know what I'm getting into. Or at least I'll gather some experience, right? So we can do actual progress. I don't know how close or how far we were from I'm doing the dude. This is the wrong one. Which one's the right one? It's 8C, right? 8C. It's this one. This is not a function. Oh, it is a function. Sub. I don't know what sub is. I don't know if it's a function or not. I don't know. I'll figure it out. I'm gonna figure it out. I'm gonna do one by myself instead of just coming in blind. It was a recipe for disaster, but I was not expecting to be able to do a function. But yeah, that's it. I am now going away. Christmas disappearance mood. Dude, I love Christmas. I will not get into it now, but there is a bunch of grumpy people out there that do not like Christmas. I say Christmas is the best part of the year. I always look forward to it. I always have fun. Yeah, that's it. I'm gonna get some food, maybe watch some tutorials or find documentations to read. Because I got myself a new, I forget what new folder for just stuff I like and I want to fill it up. See you guys later. Bye.